Hey everybody, Mr. Gibson here. So I wanted to record a video going over the summary overview page for the 4.4 interactive notes so that you can go through and check and make sure you had the correct answers. So if you haven't done that yet, make sure that you pause the video, go attempt the summary page or finish the notes if you need to, and then come back and make sure that you're doing this just to check your answers, not necessarily to write these down for the first time. Okay, writing down a whole bunch of chemical symbols and not knowing why you're writing them isn't going to help you very much. But the best way, especially with this section of the unit, to get really good at this is practice. So make sure you've practiced this, and that now you're here just double checking you got these right. So, okay, let's go through these step by step and see how we did. Okay, so the first section here says give the chemical formula based on the name. So what you do here is you simply look up the name of the atom on the periodic table that it's giving you, and you write the chemical symbol and the charge. So sodium is in group 1A, so it always has a +1 charge. Chloride is in group 7A, so it always has a -1 charge. And then you do one of two things. You could either do the counting ions method, where you count them out and literally list them until their charges cancel each other out or add up to 0. And that's what's been done here in the demonstration. Or you could do the crisscross or swap and drop method, where you just crisscross the numbers, drop the charges, and that gives you the subscripts for the formula. Both are perfectly fine. Crisscross is a little bit faster, but the counting ions is probably a little bit more reliable because you don't ever have to cancel out any common multiples of the subscript. So however you want to do it's fine. So this first one, sodium had a +1 charge, chloride had -1. +1 and -1 already cancel out. So guess what? You just need one of each ion. So its formula is NaCl. Okay. Magnesium oxide. Magnesium is in group 2A, so it has a +2 charge. Oxide is in group 6A, so it has a -2 charge. Well, those also already cancel out. So you just need one of each for those charges to add up to 0. And so its formula is MgO. Okay. Potassium phosphide. Potassium is in group 1A. Phosphide is in group 5A, so it has a -3 charge. Well, if you just have one potassium with a +1 charge, that's not going to cancel out a -3. So we need 3 potassiums so that the overall positive charge is a +3. 1 + 1 + 1 is 3. Okay, and that will cancel out the -3 charge on phosphide, which we just need one of. So the formula here is K3, because you needed 3 potassiums, P for phosphorus, K3P, okay? Beryllium nitrate. Beryllium has a +2 charge because it's in group 2A, and nitride has a -3 charge because it's in group 5A. So you need 3 berylliums to add up to 6, and you need 2 nitrides to add up to -6. So this one was a little tricky because at first you may think, well, how can I get a +2 and a -3 to cancel out? Well, you got to think, what's the closest common multiple of 2 and 3? Well, the most common multiple is 6. So if you can get both of those numbers to 6, then they're going to cancel out. So you need -3 2 times to get to -6, and you need a +2 3 times to add up to +6. Positive and -6 cancel out. So your formula is Be3N2. Remember, those subscripts are just giving you it just tells you how many atoms there were. Okay. Here we have calcium carbonate. Calcium is +2. Carbonate is CO3 altogether. It's a polyatomic ion with a -2 charge. Okay. +2 and -2 cancel out. So you just need one of each, Ca and then CO3. All right. Tungsten 4 sulfide. Tungsten symbol is W, and the 4 tells you that its charge is a +4. Okay, it's a transition metal, so we would need that Roman numeral there to tell you what its charge is. Okay, sulfide is in group 6A on the periodic table. It has a -2 charge, so -2 on its own will not cancel out a +4 on tungsten. But if you have 2 sulfides, each with a -2 charge, that will add up to a -4. +4 and -4 cancel out. So we have a net charge of 0, which is what we want, and the formula is WS2. You can see here platinum 3 nitride is PTN, and manganese 2 chlorate. Manganese has a +2 charge that needs to be edited. So good thing you're watching the video. Manganese has a +2 charge. Okay. Chlorate has a -1 charge. If you were to swap and drop, what you would get is manganese with chlorate wrapped in parentheses and a little 2 outside of the chlorate, showing that you needed 2 of them to cancel out the +2 charge on manganese. All right, and then down here, the last section just has you give the name of the compound when you've already been given the formula. Okay, so this first one, K is potassium, SO4 is polyatomic ion, and its name is sulfate. Okay, Na is sodium, OH is hydroxide. Pb is lead. Lead is one of those ions that can have more than one charge, so you're going to need a Roman numeral. Now, I'm going to walk you through how to find that Roman numeral. Chloride is Cl, okay, or Cl is chloride. It always has a -1 charge, but you have 2 atoms here. So -1 times 2 gives you -2. So for lead to be able to cancel out the overall -2 charge, lead's charge must be a +2. And you're going to indicate that with a Roman numeral, lead 2 chloride. This next one is sodium chromate. CrO4 is chromate. Okay. Here we have copper 2 nitrate. NO3 is nitrate. It has a -1 charge. You have 2 of them. So to cancel the -2 out, you need to have a +2 for the cation's charge. So that's why it's copper 2. Here you have chromium chromium 9 phosphate. That's unique, isn't it? Phosphate has a -3 charge. There are 3 of them here. 3 times -3 is -6, or -9, sorry, basic multiplication there. And so to cancel out the -9, you need to have a +9 charge on chromium. Here we have strontium fluoride. Strontium is not a transition metal. It's in group 2. We always know it has a +2 charge, so you don't need the Roman numeral to tell somebody that when they're reading the name. Here we have vanadium 3 phosphide, rubidium sulfide, tin 2 arsenide, sodium, and then Cr2O7 is a polyatomic ion. You got to treat that as kind of one unit, and its name is dichromate. We have cobalt 3 periodate, lead 3 sulfate, and finally barium acetate. C2H3O2 it looks kind of big, but it is one polyatomic ion with a -1 charge. So it is just barium acetate. Okay, hopefully this wasn't too tricky for you. I personally think the trickiest part is the polyatomic ion names, and the best way to get those is simply to memorize them. If it ends with 8 or "ite," that's a pretty good indication that it's polyatomic. If the root of its name, like hydroxide, is not a root of something on the periodic table, then that's a pretty good indication that it's also going to be polyatomic. But you've got to be able to identify those by name, and then given the name, you must be able to identify those by formula. Okay? If you guys need any help with this or any further clarification, please let me know, and good luck.